In this video, I'm going to walk you through the apparel supply chain simulation based on the Hyperledger Fabric traceability framework that we designed and developed that I'll provide the link for in the video description. We presented it at this conference, so let's go ahead and take a look at the PDF. The actual network that we're going to be simulating right now is this. As you can see, we're splitting it into two channels, and we have 7 nodes or stakeholders in our entire network. And this is the entire network topology essentially. And you can read the paper to find justifications for the design choices. Anyways, let's open this on GitHub. I tried to put in detailed instructions on how you can replicate this entire simulation on your end. As you can see, we start with the prerequisite software, and we can, I guess, just move on to installation. So the first thing you need to do, obviously, is clone this repo, which I've already done. So I'm going to resize our windows here. So this is the cloned repo on Visual Studio Code. And the next thing we're going to do, and I'll do this in tandem so you know exactly what I'm doing, is open a new terminal. And just to make sure we're right place, yeah, we're in the right place. We're going to copy the install script for Fabric. And that's what's going on up until, that's what's going on here. And for the remainder, starting with this stuff, all that's doing is letting our system be able to, or our user be able to execute all the scripts inside our current directory and the newly downloaded Fabric install script. So all it does is, of course, download the script and make it executable. And the next thing that we need to do is go ahead and run that script and install the binaries of this version, 2.5.9. So we didn't have this folder before, we didn't have this folder before. These are the folders that we just downloaded with this script. As you can see, the bin and builders directory were added. And the last step we need to do is we're just going to clear our terminal. Resize it a little bit because we have no file open right now. We're going to navigate to chain code and specifically the admin channel. And as you can see, the admin channel right now has only these files and folders. So the next thing we need to do is go mod vendor, which essentially just downloads the dependencies that are mentioned in the code. So that this directory here wasn't present before we just ran the previous instruction, but now it's there. And we're going to do the same thing for our production channel directory, which is run go mod vendor. And again, when I look inside my production channel directory, we see a vendor folder. All right, so this is pretty much it. We've installed all the required materials. Now that we're done with the installation steps, let me go ahead and clear the terminal, and we can move on to usage. So again, this is the network topology that we're working based on, right? And let's get started with creating our admin channel. Now, the thing that's actually being simulated is the creation of shirts, okay? Because shirts have a bunch of different production steps, such as what is shown right here. So this figure 4 is the entire production trace that our blockchain contains transactions of from the different production stakeholders. Let's go back to usage. What you're seeing here, of course, is only going to be reflected in the production channel, not the admin channel, because the admin channel contains higher level administrative tasks, such as certifying which upstream suppliers are even allowed to partake in the production channel based on whatever, metrics the admins would have. Like a retailer would have a set of expectations and certifications that they would require a raw material supplier in their network to have in order to produce for them. So that is not what is in the production channel. All that stuff is in the admin channel. So with that said, let's go back and actually see how we can generate our admin channel trace. We're going to have to first take a step back, right? So we're here. We're going to have to go to our test network directory. And once we're here, we're going to ensure that the necessary Fabric binaries are accessible in our path, and all relevant variables. Again, resize a little bit. So anyway, you can open this on your end and you'll understand what I'm saying. So let's go ahead and hit enter. And now we're ready essentially to, interact with our network. And obviously right now our network is down, but we'll still just run our network script with the down argument just to ensure we're starting from a known initial state. And the neat thing here is, of course, we have the Docker extension enabled, so we can just see everything from our VS Code IDE. Now that we've ensured that our network is down indeed, we can start the necessary containers and join them to the admin channel. So let me go ahead and run that script, which is network setup. And this is a script that I've created. So you can see that we're essentially creating 3 containers, pure 0 for org1, org2, and org3. That corresponds to these guys: retailer, buying agent, and the third-party auditor. Now, the blockchain consultant is an ordering service. It's actually done automatically if you're familiar with Fabric. So here, we've created containers for retailer, buying agent, and auditor, and of course the orderer, which was done by default. They've created a channel called the admin channel with retailer, buying agent, and auditor. And now let's go ahead and take a look at what exactly happened. So here is the network setup script. I have these functions, right? As you can see, this creates the admin channel and the containers, and this contains the production channel and the containers. If we modify the calling of this script by appending a 1, we will be able to start the production channel, without which we won't be able to start the production channel. So the way we've called this script right here, the production channel hasn't been created, and that's reflected in the output, right? But if we just simply added a 1, the production channel would have been created. As you can see, if the containers are already running for the nodes and this function is called, then it doesn't recreate those containers, right? That's what's happening in the if else. Again, I encourage you to look at this script and really study it, because this is essentially what's creating channels and what automates the channel creation and the container creation for whatever is necessary, depending on the functions that are being called. And if you look inside the specific script that this script itself is calling, for example, this add org4 script, which is inside the add org4 directory, you will be able to see even more details, but I won't get into that for this video. But I do encourage you to really look at that and see how it achieved all that's going on in this script. All right, so now that we've gone over what's going on in this script, obviously the necessary containers for the admin channel should be created. So just to check, we can check out our handy Docker extension in VS Code, and yep, we have these containers that correspond to these guys right here. All right, so with that, let's go ahead and package and deploy the admin channel chain codes to generate the trace that's discussed in section 4.3 of the paper. So before I do that, why don't we take a look at what's going on in that script, right? It's this initAdminLedger script. First, we're just ensuring that when the script is called, we're calling it from within the test network directory. Again, just relevant binaries in our path. This is the actual trace that's occurring in this admin channel. I'm just going to zoom in a little bit so it's easier for you to see. Step 1, we're going to generate an order as the retailer. We're going to enter our upstream factories or stakeholders corresponding to this guy, and this guy. We're going to then approve those factories as a retailer. We're also going to have to approve those factories as an auditor. Again, this is org1 and org3. Org1 is the retailer, org3 is the auditor, and org2 is the buying agent. We're, step 5, going to set the factory status now that they're approved by the retailer and auditor. We're afterwards going to issue a plan as a buying agent. We're going to approve a plan as a retailer. We also have to approve that plan as an auditor. Once we do all that, we're going to update the plan status field now that it's approved by both the retailer and the auditor. We're going to accept that order as a buying agent, given that the plan has been approved by the relevant parties. And once all that is done, we're finally going to update the order status because it is accepted by the buying agent. So these are the 11 steps that we're going to simulate using this script. And of course, these are all going to be essentially transactions that are going to be recorded in our blockchain ledger. So let's take a gander at the initAdminLedger script. Step 1, generating the order as a retailer. set globals 1 essentially lets us act as org1, in this case the retailer, when we're invoking whatever command comes next. In this case, it's the invocation of the chain code. And specifically, the chain code is directed at the admin channel, and it's called admin, and it's targeting orgs 1, 2, and 3, and of course, it lets the orderer know. And the specific chain code that's being called is create order, and the following are essentially just arguments for the create order function. So let's take a peek now at the create order function, and we find that inside the chain code directory, inside admin channel, and admin smart contract. So let's open this to the right, and let's minimize our file explorer view. Okay, so create order is defined right here, right? And of course, these are the arguments that it needs, the parameters, and the definition starts from here. The first thing that's happening is that it ensures that whatever ID we supply it, in this case, this argument right here, it begins with an order underscore, and that's fulfilled using the spec function. So let's open this spec functions file, which is defined inside admin spec functions.go. And as you can see, this simply will return or throw an error if the ID does not start with whatever the argument requires it for it to start with. So in this case, the argument that we've set is order underscore. So it'll throw an error, of course, if the order ID doesn't start with an order underscore, right? And so on and so forth for each of these spec functions. And I encourage you to read these functions and study them so you can modify it however you want for your chain code. All right, so here we're creating the asset for an order. And keep in mind that obviously at this stage, since this is the first step, this order can't be accepted at all. So we just default the is accepted state to false, right? It's only capable of taking a bool, so it has to be true or false, and we just set it to false. And the status is, again, hard-coded to issued, given that the order has just been issued. Spec chronology is an interesting specification function because it ensures that the created at field precedes the updated at field, which precedes the delivery date field, right? These things make logical sense. And of course, the order has to be converted to JSON and then saved to the state, right? That's what's happening. So that's basically what's going on in this create order function, all right? So once that goes through successfully, this check status, again, which is in our path, will show a tick mark next to creating order. And then we sleep for 2.5 seconds just to ensure that the state is updated before going to the next step. Okay, this will become more important in the production channel trace, but for now we're just going to stick to the admin channel trace. So step 2 is, again, from the perspective of the buying agent, right, org2, who at this point will enter the upstream factories to the world state. And those factories correspond to the full package supplier, the raw material supplier, and the textile manufacturer. So as you can see, there's one chain code invocation, there's a second chain code invocation, and there's a third chain code invocation. The first one has the raw material supplier, the second one is about the textile manufacturer, and the third one's about the full package supplier. And again, if we check out the create factory function, so create factory, right here, again, the ID prefix is checked with factory underscore. So this asset has to have a factory underscore at the beginning as a prefix of its asset name. The factory, of course, can't already be in the system if you're calling create factory, and it ensures that by ensuring that the factory ID is unique at the time of the function invocation. It's valid. And the default things that are coded here are, of course, that the factory at this point can't be auditor approved, and neither can it be retailer approved. So those are hard-coded defaults. And the status of the factory sort of approval is obviously pending, right? And the updated at is, of course, the time at which this function is called. So that's also hard-coded. So we're not allowing these stakeholders to manually set the updated at time to sort of game the system, if you will. Okay. Again, we sleep for 2.5 seconds after that. Now, in the third step, we go back to acting as a retailer, and we manually need to approve the factories. So let's take a peek at set factory approval. So all you need to do to invoke this function is first, you need to adhere to this spec function, which is spec is invoked by allowed org. Now this function ensures that only org1 MSB and org3 MSB, meaning only the retailer and the auditor are capable even of invoking this function, because at the end of the day, only they are allowed to approve factories or upstream suppliers. The buying agent can't. He can propose an upstream factory, but he can't, approve them per se, right? So that's the first thing that's going on there. And of course, if you look at the chain code invocation, other than setting our, setting ourselves as org1, there's nothing inside the chain code invocation that lets the order or any other stakeholder in the system know that it's actually org1 that's calling this function, because the chain code is going to first be validated in your own server, right? In your own local host. So it's going to check immediately, are you org1 or are you org3? And only then will this spec even be satisfied for it to go to here, right? So here is just retrieving the factory from the world state, whichever factory, in this case it's factory 1, and if that factory exists, and if you are a retailer or an auditor, it approves that factory if you so wish, right? So that's what's going on in step 3. You're approving it as a retailer, and the same thing is going on in step 4, except this time you're approving it as an auditor, right? So the 3 factories by the end of steps 3 and 4 have been approved by both retailer and auditor. Step 5, we are now setting the factory status because they've been approved by the retailer and auditor. Now notice that the set factory status doesn't take status as an argument. It simply just tells the chain code that, hey, I want you to set factory status for the given factory. I guess I could rename this update factory status, given that all it does is check based on what the approval rating currently is. So as you can see, this set factory status only takes factory ID as a string, and that's the ID of the factory, of course. And if the factory is both retailer approved and auditor approved, and there aren't any flags in its state, only then is the factory status updated to approved if all those conditions are met, right? And of course, it adds a timestamp to the factory state, and it marshals that and puts it back into the world state, right, as a JSON. Okay. Step 6. Now that the factories have been approved and their factory status is set as approved, we can issue a plan as the buying agent, right? org2. So we set ourselves as org2 now, and we create a plan. So let's check out create plan. So create plan issues a new asset to this state with the following attributes, right? You have to give it a string of the factory ID. So which factories are you going to provide this order to upstream suppliers to fulfill this order, right? So again, the same old. And for each factory that the buying agent supplies, the chain code checks, does that factory exist? Initially, factories might not be approved. So you go ahead and check all that, right? Once, in this case, the plan has been issued, you move on to approving that plan as a retailer. So we go back to set plan approval. Now set plan approval is quite similar to set factory status or whatever, because it just approves the plan based on satisfying conditions. So in order for the plan to be approved, it has to be approved by the retailer, it has to be approved by the auditor, and of course it can only be called by a retailer or auditor, right? A buying agent themselves can't approve the plan. And of course we have to run this from the perspectives of an auditor as well as a retailer. So once all that is done, we have to update the plan status, similar to how we had to update the factory status, right? So if we go to set plan status, all it does is simply ensure that all factories have been approved in this plan, and only then can this plan itself be approved. So the plan approval just from the retailer and auditor themselves is insufficient. It also needs to ensure that all the factories have been approved prior to updating the plan status finally. Now, once that has been updated, the plan status that is, we can go ahead and accept the order as a buying agent. So set order acceptance. So of course, if the order doesn't exist, it won't work. If the order is not legible, it won't work. If you can't, unmarshal it, that won't work, of course. And only the order can only be invoked based on who was set as a receiver of the order in that order's original, state. And once that plan that is set to satisfy that order is ensured to exist, we update the plan field. Um, we update the plan field of the order itself. We ensure that it's accepted, and of course the timestamp related to that. And finally, we update the order status now that it's been accepted by the buying agent, right? And that's the last thing we have to do in the admin channel, of course, is set the order status, right? Just supply it the order ID and the new status, which should be order one and accepted. So I've walked you through what theoretically is going on based on our chain code, and of course you're free to study the spec functions, and the audit functions are something that you can apply retroactively or at any point during the lifecycle of the ledger. But let's go ahead now and actually run the initAdmin ledger. So let's just call it ledger. So obviously the first thing it's doing is deploying the chain code on the admin channel. And let's take a look at our Docker extension to see really what's going on as it's deploying that chain code. So you can see there's new images being created. There's the container of the chain code. And this takes a while, so you got to hang in there. So you can see that's the package chain codes. And of course, we run into an error. Specifically, there's an endorsement failure during invoke, and because of our verbose output, we can see that it didn't even pass step one. All right, so the create order command failed, and specifically, there was a 500 error message, and the message is that the date is not after that's today. So, well, this is, I guess, a good learning experience. If we go back to step one, and let's minimize this, and let's take a good look at that. Okay, so this is the date, right, that I've hard-coded for the order creation, right? Or rather, this is, if we go create order, so the first time is the created at time, and the second time is the delivery date. So you can see that we've created this order on the 10th of May in 2024, and the delivery date is for the 1st of Feb 2025. Now, I'm recording this on the 27th of Feb in 2025. So the failure here is actually probably the chronology failure, which is that the created at time is 10th May, which is actually before the updated at time, but the updated at time is not before the delivery date. In fact, the updated at time, which is this time here, is actually after the delivery date, which is this date here, right? So that's what's failing, and that's why the command wasn't able to go through. So let's restart by shutting our network down, right? Just so we know we're going to a known state. So let's watch all these get pruned or purged and all that, right? So we're starting from a known state, which is always a good idea. All right, so we're going to set up our network again, which is going to recreate those containers. Right? And while that's going on, let's change the delivery dates, right? Let's make sure that it's indeed after today. So we're now changing it to March. All right, so I'm not sure if the script makes logical sense anymore in terms of the dates, but that's kind of trivial for the point we're trying to make with this script, right? Okay, so let's clear our terminal, all right? And let's rerun initAdminLedger, and hopefully this time we should see it go straight through. So again, it's deploying the chain code admin on the admin channel. Again, this is just the name of the chain code, which is hard-coded right here. If I changed it over here, it would have said something else here. If I changed it in the script, that outputs whatever's coming on my terminal. Okay, so there we go. The command succeeded. It created an order. Then the ledger created, the factories were added to the ledger. They were approved by the retailer and then the auditor. The status was updated for each of those factories. The plan was issued by the buying agent. It was approved by the retailer and then, of course, approved by the auditor. The plan status was therefore updated, and the buying agent accepted the order after the plan status was updated, and finally the order status was updated. So those were the 11 steps, right? And what I did after those 11 steps is um, we reach here, right? And that's essentially printing lines to the terminal. So you can see here are all assets in the ledger after execution of all init commands. Again, here are all assets in the ledger after execution of all init commands. These dashes, and then we query the chain code. Now, again, based on the endorsement logic, anyone can query the chain code in this channel. Um, and so it doesn't really matter who's doing this, but of course the last set global was 1. So this is obviously being done through the lens of the retailer. So they're querying the entire chain code and they're getting all assets that were just recorded on this chain code, right? So let's see. There's factory 1, there's factory 2, there's factory 3, then there is the order, and there's a plan. And the plan is the upstream suppliers that will satisfy this plan, of course, factories 1, 2, and 3. The plan is retailer approved, it's auditor approved. The production plan is to add the raw material suppliers, textile manufacturer, and full package suppliers. The status is updated today, of course, at this time. And yeah, that's pretty much it. And of course, this was all automated because of this script right here, where we essentially automated the, who's running what, who's invoking what chain code. So now that that's done, you can essentially open the audit functions file and, interact with the ledger. So I'm just gonna get rid of this stuff here, make it a bit smaller. So, we can go ahead and run asset exists or set a flag or set notes. I really encourage you to actually clone this repo and play around with it, change the functions, modify them, even go ahead and use this as a base for your project. Yeah, so I've shown you how to simulate the admin channel trace. Now I leave it up to you to simulate the production channel trace. A quick note on the production channel trace. As you can see, for the admin channel, we only had, that breakpoint. For the admin channel trace, we only had the one file. But for the init production ledger, we have multiple files that are suffixed by a number. That number corresponds to the amount of shirts that are actually being produced. So init production ledger underscore 20,000 actually produces 20,000 shirts, whereas init production ledger 200 will only produce 200 shirts. So if we open this file, you can see that these are the 11 steps that are going on here. And the key difference, really the only thing that's different, is all these raw materials that we're generating, the amounts will differ based on whether it's a 200 shirts order or whether it's a 20,000 shirts order, and everything in between. And of course, you can see how that impacts performance by looking at these graphs here. And of course, this is all in the paper. So I think this is a really solid base for you to play around with Hyperledger Fabric, get used to it, modify it for your use case, and basically rely on this as a template for whatever you have in mind. Good luck. Thanks for watching.